In today's lesson we're going to look at the structure of an Arduino C program. We're going to look at things like variables, loops, and the various structures that Arduino expects from us. And we're going to look at the Web IDE, Integrated Development Environment. We'll finish by creating two scripts, two sketches. The first is one we're already familiar with, which is the blink sketch, which is installed on the Arduino Uno by default. But then we'll look at Hello World, how we can interact with the Arduino serial monitor and create some interactivity. Let's get to it. So this is the Web IDE, and I'd already signed up, so I can just click login and it'll set up the browser for me with all of the menus and options and my existing sketches. And as you can see down here, I've got a whole bunch of sketches that I'd already created. For example, this is the Stitch Kit example, and it's saying no plugin connection, uploading is disabled. Well, I've got the plugin installed, so let's reinstall the plugin and make sure it works correctly. While we're here, as you can see, it does have some restrictions on which operating system you can use the web plugin with. So if you don't have one of these operating systems, that's a good reason to use the Arduino desktop IDE, because that has a lot more flexibility in what you can use it with. In fact, you can even install the desktop IDE onto a thumb drive, which I haven't tried yet, but I will investigate and I'll share with you if it's any good. Anyway, onto the plugin. So now you can see we're all connected. Arduino Uno at USB modem 1414210. Awesome. So here we have an empty sketch, and can create a new sketch simply with new sketch. You do only get 100 sketches, so that's worth keeping in mind. It's a free plan, so you know we can't complain too much, and I don't see anywhere where we can actually upgrade the plan, so you probably have to delete sketches as you go through them. But yeah, it's worth keeping in mind. I've used 21 sketches of my 100, and I've used 5%. I wonder if there's an upgrade option yet. No, you can't upgrade. And you can actually import your existing sketches into it if you've been using the desktop. So the main reason that you would use a desktop is if your device isn't available in this list, because only a selection are available, or if you want to use more space or more sketches than are available to you in the restrictions here. But let's look at creating a new sketch. So first we need to look at the structure of an Arduino sketch. So they just call the program sketches, and that's because of the relationship with the processing application, which is a sister app to Arduino. on screen you can see the three areas of a sketch. Yes, Arduino is C, but it gives you a little bit of help. It gives you a bit of assistance in setting up your script, your sketch, so that you don't have to do a lot of the things that you ordinarily would. So behind the scenes, it's doing a lot of work for you. The IDE will actually launch the open source C compiler in the background. It'll compile everything, include all the libraries, all of your code together, and it does that all transparently. It does it all for you, but you could actually use all the command line tools and do it yourself if you wanted to. So the three areas are this area at the top, which right now is a multi-line comment. So we put and they're delimited by slash asterisk and finished by asterisk slash. You can also do a single by doing double slashes. And the other part that you'd want to put at the top here, so as well as like describing your program and what it's intended to do and who wrote it, is declare some global variables. So we'll go deeper into variables later, but for now just know that that is how you would have a global variable. And global just means that it's available to every part of your program, whereas a local variable is only available locally. So within setup, for example. Now, the other thing you can do is, as well as having a variable, so variables are things like counters or temperature, right? You can also have constants, and the way you do that is with define. So you say my constant has the value of whatever your value is, and very often people will do the constants in uppercase, so you know. So that is all stuff before the program really starts. So you can set some variables, which are just little boxes to put values in. You can set a constant value, so very often we'll say my LED is on pin A0, and then it goes to these two places here, which are subroutines or functions that always have to be present. And the setup, as you can see here, is where we do setup. It is the first thing that it runs after setting up whatever you've put in here. Setup always runs next. We'd start the serial monitor, we would set up some variables, and we would configure things, maybe even load some data, and that would be the setup. The loop, as the name suggests, is a loop, and it goes on until the program ends. It keeps looping round and round and round until, for some reason, it quits or you reset. So obviously when you reset, it will do all of this again. It would do the setup, and then it would start running the loop again. So the loop is the place where most of your magic happens. And behind the scenes, there is a call to this loop, and it's an infinite loop. But afterwards, it also checks the serial, so it doesn't interrupt checking to see if there's some serial input over the USB or over the pin serial connections, or if you've got any output. So the loop will actually execute, then it'll check the serial, then it'll loop again. But we can ignore all that, it's done for us. So that is the structure of a script or a sketch, but let's have a look at some of these examples. And the first that everybody always does, as we saw already with our breadboard, is this blink example. So you can see we've got multi-line comments, that's the description of how it all goes together. We've got some setup, and it's saying set the mode of the built-in LED pin, which is number 13 on the Uno, as an output. So we're outputting current to pin 13. So the Arduino knows that that pin is an output pin, not an input pin. In the loop that goes on forever and ever and ever, we send a digital output of high, which is a 1 or a yes, a binary 1, pin voltage high, so it's sending 5 volts to this pin. It waits a second, 1000 milliseconds, and then it sets it low or 0 or off. Waits again, and then it loops round. So it blinks on and then off. So if we don't have an LED plugged in to pin number 13, then it'll flash the internal LED, which is on the same pin. So it, on, wait, off, wait, on. We can check the code with verify, and so that'll check to see if everything we've typed in is correct. It's verified, it's fine. It gives us some more information down here. It says how much space we're using 2%, and it says it's all good. So we can now use the upload button to send it to our Arduino. So it verifies it again, saves it to my sketchbook, and then it uploads it to the Arduino. It's doing it over USB, the serial. It flashes, so it writes it to the flash, and you can see AVR Dude is the programmer application. AVR is the type of chip it is. It's going over the serial which I selected earlier, and it's written it away. And now if you've done the same thing on your board, it'll be blinking.